Welcome to the webinar, Reducing Methane in Residential Water Well Systems. I'm Cliff Tryans, Director of General Public Outreach for the National Groundwater Association. It is my privilege to introduce our presenter, Larry Zinser, a master water conditioning in Pottsville, Pennsylvania. For more than 20 years, Mr. Zinser has been involved in the design, manufacture, and troubleshooting of water treatment systems. He has taught numerous accredited technical courses throughout the country and internationally. His background includes the industrial, commercial, and residential sectors of water treatment involving a wide range of technologies. During the presentation, feel free to type questions in the question box and hit send. At the conclusion of Mr. Zinser's presentation, he will answer your questions. Also, at the conclusion of the presentation, we will make a handout of Mr. Zinser's presentation available for downloading. So without further delay, I'll turn it over to you, Larry.
Thank you, Cliff, and good afternoon and welcome. This training will take about 20 minutes or so, and remember, the time that you invest in this could protect your drinking water quality and your health. The purpose of this presentation, sorry for the delay there, the purpose of this presentation is to explain the hazards of methane in well water and the methods available to treat it. As with all potential contaminants, a routine well water inspection can help ensure the well system is operating properly, prolong the system's useful life, and discover water quality health risks due to system maintenance or to contaminant sources. Methane is a gas that's common in nature. It's also called marsh gas. It is the most simple of hydrocarbon compounds consisting in one carbon atom and 4 hydrogen atoms. It's not like radon, it's not poisonous, and it's not carcinogenic. It's also not like hydrogen sulfide, which has a strong rotten egg odor. Natural methane is odorless, and therefore it's difficult to detect. Commercial energy gases for homes, including methane, propane, have an additive called a mercaptan, which gives the common commercial gas odor. But remember, methane, natural methane, is odorless. Methane is a natural gas. Most of the methane on Earth comes from, whether it comes from geologic fissures or from decomposition of organic matter, it all comes ultimately from microbes called methogens. Methogens are present in all wetlands and in the digestive tract of humans and ruminants, like cows and things of that nature. Methogens turn and convert carbon dioxide into methane. Methane can appear as bubbles in a gas, or it can be dissolved and be clear. You cannot see it. Just very similar to a carbon dioxide gas. According to Henry's law of physics, a dissolved gas will be released from a solution when the pressure is decreased. It's like opening up a can of soda. Once the pressure is reduced by removing the cap, the carbon dioxide comes out of solution and into the air. The same thing happens when well water is first exposed to the atmosphere. The release of methane in the air from dissolved is accelerated by lower pressure, higher temperature, and a larger surface area. You'll notice aeration faucets. What they do is they expose a large amount of the water to the air. This is creating larger surface area. Most of us are aware of the explosive properties of methane gas. It is a combustible gas. This explosive property of methane is in concentrations between 5 and 15%. Once the methane reaches the 5%, all it takes is a spark. Methane released from water supply can accumulate, especially in unventilated enclosed spaces like basements or well houses, wherever there is no way for air to circulate within the confined space. Higher temperatures and a lack of ventilation can create an area which is susceptible to the accumulation of methane. If enough methane accumulates in a space, it can then become explosive. Remember, as little as 5% makes for an explosive mixture. Ventilation can keep the methane concentration low. But besides explosives, there are other health risks associated with methane. As with any gas, when enough of it displaces the oxygen in the air, suffocation can ultimately result. Our breathable air contains about 21% oxygen. When that percent is decreased by only 2%, the symptoms of hypoxia, including headaches, decreased coordination, impaired vision, nausea, etc., leading to suffocation may occur. It doesn't take much, but prolonged time can cause hypoxia to take place. Well, is my private well at risk? Because methane is so common, it can affect any well. In fact, more than half of the wells are affected by methane in some concentration. It may be very small concentration at times, but that concentration can also change over time. And we'll say a few words about that in a moment. Methane is not classified as a hazard, health hazard rather. There is no maximum contaminant level established by EPA for methane. It's not poisonous, it's not carcinogenic. But states have established guidelines for the level of release of methane from the ground. Methane is a greenhouse gas, and this is why. Regulators are aimed at the emission of methane by industry, especially the oil and gas industry, where emission standards are established by states. The presence of methane can change with the season, and it can also change due to geological changes, shifting in the ground under our feet. So for new wells especially, seasonal testing is recommended for all contaminants, including methane, because other contaminants also have the propensity to change their strength during the seasonal changes, based on the flow of water within the aquifers below the ground. Since methane is odorless, tasteless, colorless, it's obviously difficult to detect. But only 10 parts per million of methane in air should be of some concern. So how do I test for the presence of methane? Well, unfortunately, testing for methane is not as easy as testing for hardness or pH. There's not a little test kit with a couple of reagents to change colors to check that. Testing by a professional is recommended, which have the instruments, etc., to be able to determine the exact concentration of methane. So if I have methane, how do I address it? Well, unfortunately, not by traditional methods. It's not a gas, so it can't be filtered. It's not ionic, so it won't be removed by ion exchange like we do with softeners, and it does not absorb the carbon. The answer is ventilation. Remember that the hazards of methane are explosion and hypoxia. So ventilation removes these hazards. If any methane is present, then a venting system is necessary, like this venting system at a wellhead, allowing the methane that accumulates within the well to escape into the air. Remember, methane, though, can be aware in bubbles. It can also be dissolved. So even with a vent, some of that methane could pass over through with the water and get into the treatment system in a home. If left unvented, the gas bubbles can accumulate anywhere within the water treatment system, just like a gas. Even within a pressurized tank, the accumulated bubbles can the bubbles can accumulate at the high point of that vessel. When venting, always consider the location of the vent. Obviously, we don't want to vent the methane into an unvented basement or utility room. It should be open to atmosphere where it can readily dissipate and move into the air. An aeration and venting system may release the methane. This system here has a mechanical float which allows excess gas to vent. And in this model, essentially the gas would accumulate at the top, creating a larger and larger bubble. And once the bubble gets large enough, the gas will then be vented through the vent distributor seen here. And that's the way it would remove from the water. But obviously that vent should be open to atmosphere. So some things to remember about methane in wells. First of all, it's very common. It can lead to explosions, or it can also lead to hypoxia. Professional testing can determine its presence, and it can be reduced through ventilation. When looking for an answer on methane, we always recommend working through a organization which subscribes to third-party organizations to establish the credential of their service and their products. Before we leave, I'd like you to please put on your schedule to join us for additional webinars in the future. One on iron and manganese, of course, two of the most difficult challenges in water treatment, fluoride, and also your basic water treatment maintenance basics. Thank you. Are there any questions?
Okay, thanks, Larry. I'm going to ask people to go ahead and submit their questions as we answer a few here. And again, you could just go to the little question box in that little panel on your screen and then type in your question and hit send. So before we get into questions, Larry, that last photograph that you had of some people standing around what appeared, yeah, that one right there. What is that? Is that are they on a pond or something? Or
Yes, they are.
I couldn't quite figure that.
Yeah, that's a pond, and you know there's a reason why it's called marsh gas, because a lot of the microbes, methogens, live in marsh areas, and in the winter, if there's any methane left in the ground, it rises to the top of the ice. And in this indication here, they opened the right spot, and the marsh gas coming out of off the top of the ice.
Well, it's not a campfire, but it's close.
No, no. You might be able to light a fire, but I guess I don't know.
Wow, something else. Well, okay, I want to go ahead and hit you with a question.
Sure.
First question, I'm curious. Those people lighting their faucets obviously have a methane problem. Why isn't there an explosion? It says that lady is smiling. Shouldn't she be concerned?
That's an interesting slide because it does create some questions. Here there's only a small amount of methane in air mixture. It's right at a faucet, and it's as it's coming out of the faucet. So there's not an explosion. If that faucet were left open over a period of time, and that were a confined space, the methane and air would mix within the room, and then you would get an explosion from a spark. As far as her presence, well, she may have been posing for a photograph, and this might have been her time to have her claim to fame. But seriously, there are a lot of methane's been around before wells. So ever since wells have been going into the ground, methane has been present. And just like many other issues in the past, folks were just not that concerned about it. They learned to live with it. They learned the hard way that methane should be vented. So they take it for granted that the methane is going to come out of their well, and they just accept that. And this lady perhaps has been living with methane her entire life, and her father probably did, and she just shows off, I guess.
Yeah, that picture is all over the internet, so she did get her claim to fame there. Have another question. You mentioned measuring methane in the water. Should the level of methane in the air be measured? If so, who would do that?
Well, again, you'd look at a professional. There are combustible gas detectors that are available on the market. You can find them on the internet or whatever, and they either in the air or in the water will indicate a combustible gas. It may not necessarily be methane, but if it's coming out of the ground in a well, it probably is. It just measures the combustible gases. But you can get these things, if you want to spend a lot of money, or you can hire a professional to come and do that for you, to measure it.
Would that device also measure hydrogen sulfide, which I understand also can be explosive at certain concentrations?
I do not believe it measures hydrogen sulfide, but hydrogen sulfide has probably the most available instrument on the planet, which is the human nose. Extremely small amounts of hydrogen sulfide. Most folks can pick it up right away, but they're just by smelling it. It's very strong.
Yeah, now that you mention it, I've smelled that smell before.
Absolutely.
I have another question. How do I go about getting a well cap designed to vent methane gas? So that one picture you showed of the wellhead that had a well cap with a little vent device on top, how would somebody go about getting one of those?
Well, again, contact your well service organization, and as we had mentioned earlier, you would contact a well company that has an affiliation and subscribes to an organization like the National Groundwater Association, which does subscribe to the higher standard of a product. But they would be able to provide a specification and a product that could be placed on your well to add a vent.
Okay, thank you. We have a question here. I thought methane gas in drinking water was caused by fracking. How come I never heard of people lighting their faucets before?
Well, because it's in the news, and unfortunately, like most issues of the day, there are two sides to every argument. The objective of fracking is to drill down a mile deep through hard rock and to prevent the release by proper casing and cementing of the case so that you don't have the release of methane. But there is methane released. Now, the reason we hear about it now is because fracking has created an issue, and methane is one of the issues associated with fracking. There's two sides of the argument, but my own common sense thinking about it, if you're drilling a hole in the ground and there's methane in there, there's a possibility of some of that escaping.
You're from Pennsylvania, or you're familiar
Originally,
with Pennsylvania.
that's correct. Yeah.
Okay. So Do you remember issues like this with people lighting their faucets, or just the familiarity with methane in Pennsylvania long before?
Well, there's always been a methane issue within the state of Pennsylvania, just like there's always been an iron problem and a hydrogen sulfide problem. These are very common in the state of Pennsylvania. The idea of methane in wells has become more and more in the news because, again, it's related to the fracking issue. But methane's been around coming out of wells for years and years. In fact, one of the biggest problems actually in the country right now in many places is old wells, wells that have been abandoned, never been registered, because we've been digging wells for a lot of years. And some of these old wells, they're sitting out there, may have a tree stump in them or a bunch of dirt thrown in, but they are releasing methane as well. It's just not detected, that's all.
Okay, thanks. You mentioned, here's a question, you mentioned at least 3 ways to vent methane gas away: at the well, from a tank in the house, I assume, and in a room or enclosed space. You showed that, had that picture of the ventilation in the room. Mm-hmm. How do I know which option is best for me?
That's a good point. It probably the best way, the way I would approach it, if I had a well in the state of Pennsylvania and I had methane, the first thing I would think about would be to try and release it at the wellhead, since that would be the easiest way to do it. To apply a well vent and see if that will reduce it, and then I would test it in my home. If there's a lot of dissolved methane in there, then that well vent may not release all of it. There will still be some in your water when it gets into your home. Then you have to look at other methods. During the summertime, relatively easy. Open up a couple of windows and let the air come through, not a problem. The winter is where the problem comes because our windows are typically closed. If you have a lot of dissolved methane, which does not get released at the wellhead, then you'd want to look at some sort of device outside the main part of the house, which would release methane gas that's accumulated before it gets into the home. That's how I'd approach it.
Okay, thanks. Here's another question. Do I need to test for methane during all 4 seasons every year? So you mentioned how there were in the presentation about a need to do testing at different seasons because the methane level can fluctuate. Any guidance on frequency of testing?
Well, that's a good question as well. For new wells, and this goes beyond methane to any and all contaminants in the water, a new well should be tested at least 4 times a year, once in each season, after each seasonal change of climate. You know, after the snow melts, after the rains of spring, or after the end of fall, after the rains in fall, to test for all contaminants, to get a good idea of what the normal state of your well is throughout the year. Thereafter, I wouldn't recommend testing all 4 seasons every year, but periodically, like every 2 or 3 years, to go through another seasonal test and compare the results with the results you had in the new well, just to see if how much migration is taking place within your aquifer under your ground.
Yeah, I want to piggyback on that question because it sounds like is that generally good advice for testing in general to test at whatever interval is recommended for regular testing, but then, like I know for some things, the recommendation may be to test once every 3 to 4 years. Mm-hmm. But it sounds like what you're saying is to know what the recommendation is, if there is one, and then every once in a while just double check to make sure that that the testing is, that you've measured against that baseline.
Yeah, and that's the whole idea, Cliff. And you know, a lot of it depends on what the contaminants are that you suspect. If during that first year you detect some pretty nasty things in your water, uranium or arsenic or one of these, or a large amount of methane, you may be prompted to test more frequently. Maybe you want to test every year. But if your water testing is kind of normal, your total dissolved solids under 100, no hardness, no iron, no other necessarily contaminant, you may want to extend that out. But it really depends on the character of your well, and you establish that character during the first year of operation.
Okay, thanks. I have a question about the aeration tank. Question is it hard to get an aeration tank to treat methane? I've never heard of one or seen one.
Yeah, it is relatively, it's essentially a confined tank which has and I'm trying to think of the trade name for the air vent. It's a simple float vent on the top. It's a very common vent. It's used in some aeration systems, and the vent is set up so that when the pressure increases, it pushes the float up and lets the air expand without letting the water go out. Boy, I wish I was trying to think of the name, but there's a brand name associated with those vents. So it's pretty common. If you talk to a water treatment professional, I'm sure they have available, but they just fit on top of an enclosed tank, a tank that can take the pressure associated with water, which is generally under 100 pounds per square inch.
Okay, thank you. Question, why does the methane from an aeration tank need to be vented above the eaves of the house? So why does it have to be, what's significant about that?
Well, typically the eaves, there is an opening under the eaves of most houses. Most homes breathe under their roof, and by putting it above the eaves, you're preventing the escaping gases from getting into your home in any way. That's the whole idea, is prevent it from getting in the home. Okay, I might mention, Cliff, that one picture, I'll go back to it, I think this one here. This is actually from an old well, an abandoned well, and they put these high-level vents on here to let the gases escape. Putting them back in, securing the well completely sometimes is very, very costly. So you see these some places in old parts of Pennsylvania. Okay,
thanks. We're near the end of our questions, so if anybody has one, send it to us quick. I do have one more right now. Okay, this is interesting. This seems a lot different than water softening. It's water softening. Who can sell and install an aeration tank if I need one? How do I find someone to do that?
Well, your best bet would be to look to any treatment organization that subscribes to the Water Quality Association. You can go on their website, wqa.org, and they can identify water treatment professionals in your area, in your zip code area, who subscribe to WQA. And that's what I would recommend, is going through one of these professional organizations, or if it's a well, going through the National Groundwater Association. But find someone who is affiliated with a professional organization.
Okay, thanks. Well, it looks like we're exhausted our questions, but I do want to point out, if you look on your panel there, viewers, you will see a handout pod there. You can download that PowerPoint presentation. I would encourage people who are in areas where this methane is a problem, or if they know well owners who are in areas where methane is a problem, to please share that handout, and we will also have this webinar recorded and available on the internet. So you might want to go back to our website. You see the address there, www.wellowner.org, in a couple of days, and you will be able to get the link for that recorded webinar. So, Larry, anything you want to say in closing?
No, not really. I do appreciate the, thank you for the opportunity to present her. I hope my chair squeaking hasn't caused anybody to be concerned. It's my favorite chair, so.
Well, it's hard to keep all the ambient sound out of these webinars. So
yeah.
Anyway, Larry, we want to thank you, and we want to thank everyone that tuned in. And again, please share this information with others you know who could benefit from it. And with that, I wish you a good afternoon. Thank you.
Thank you.